Imagine a star so massive it could hide in plain sight. Sounds crazy, right? Picture yourself gazing up at the night sky, marveling at the twinkling stars scattered across the vast expanse of space. Among these celestial wonders, there could be a star so colossal, so powerful that it defies our very understanding of the universe. This star, though invisible to our eyes, exerts an immense gravitational force bending the fabric of space and time itself. It's a concept that seems almost too fantastical to be true, yet it was the brainchild of a visionary thinker from the 18th century. Back in 1784, English clergyman and astronomical pioneer John Michell had a mind-blowing idea. Michell was not just a man of the cloth, he was a polymath, a scholar whose curiosity knew no bounds. He delved into the mysteries of the cosmos with a fervour that was rare for his time. Surrounded by the tools of his trade, ancient manuscripts, intricate scientific instruments, and the wisdom of the ages, Michell embarked on a journey of intellectual discovery that would change the course of astronomical thought forever. He proposed the existence of dark stars, bodies so huge that even light couldn't escape their gravitational pull. Imagine the audacity of such a claim in an era when the nature of light itself was still a subject of intense debate. Michell's dark stars were not just theoretical constructs, they were a bold challenge to the prevailing scientific paradigms. He envisioned these colossal entities as cosmic traps, where the gravitational force was so overwhelming that it could ensnare even the fastest thing in the universe, light. Michell's calculations were simple yet revolutionary. Using the mathematical tools available to him, he derived equations that described the conditions under which a star's gravitational pull would become insurmountable. His work was a testament to the power of human ingenuity, demonstrating that even with limited resources, profound insights into the nature of the universe were possible. Michell's equations laid the groundwork for a new understanding of gravity and its effects on light, paving the way for future generations of scientists to build upon his ideas. He figured that if a star was 500 times the diameter of our Sun, its escape velocity would surpass the speed of light. To put this into perspective, consider the sheer scale of such a star. Our Sun, a relatively modest star by cosmic standards, has a diameter of about 1.4 million kilometers. A star 500 times larger would be an astronomical behemoth, dwarfing our Sun and exerting a gravitational force of unimaginable magnitude. Michell's insight was that at this scale, the escape velocity, the speed required to break free from the star's gravitational pull, would exceed the speed of light, rendering the star effectively invisible. A gigantic invisible star, detectable only by its gravitational effects on nearby bodies. This concept was nothing short of revolutionary. Michell's dark stars would be hidden from direct observation, their presence revealed only through the gravitational influence they exerted on their surroundings. Nearby stars and other celestial objects would orbit these dark stars in peculiar ways, their motions betraying the existence of an unseen gravitational giant. It was a tantalizing glimpse into a hidden aspect of the universe, one that would remain shrouded in mystery for centuries. At first, scholars were thrilled by Michell's theory. The scientific community of the 18th century was abuzz with excitement at the prospect of such a groundbreaking idea. Michell's peers recognized the significance of his work, and his theory sparked lively debates and discussions among the leading minds of the time. It was a period of intellectual ferment where new ideas were eagerly explored and the boundaries of knowledge were constantly being pushed. Michell's dark stars captured the imagination of scholars, offering a tantalizing glimpse into the unknown. But excitement faded when the wave-like nature of light was discovered in the early 1800s. The discovery that light behaved as a wave posed a significant challenge to Michell's theory. If light was a wave, how could it be trapped by gravity? The wave theory of light, championed by scientists like Thomas Young and Augustin Jean Fresnel, suggested that light could diffract and interfere, properties that seemed incompatible with the idea of light being captured by a gravitational field. As the wave theory gained acceptance, Michell's dark stars were relegated to the fringes of scientific thought, their once bright promise dimmed by the new understanding of light. If light behaved like a wave, how could gravity trap it? This question became a central point of contention in the scientific debates of the 19th century. The wave theory of light, with its elegant explanations of phenomena like diffraction and interference, seemed to leave little room for the possibility of gravitational capture. Michell's dark stars, once a source of fascination, now appear to be an intriguing but ultimately flawed hypothesis. The scientific community moved on, exploring other avenues of research and leaving Michell's ideas to gather dust in the annals of history. Michel's dark stars slipped into obscurity until modern science revived his ideas, leading to what we now know as black holes. Fascinating, isn't it? The 20th century brought a revolution in our understanding of gravity and the nature of the universe. Albert Einstein's theory of general relativity provided a new framework for understanding how gravity works, predicting the existence of regions in space where the gravitational pull is so strong that nothing, not even light, can escape. These regions, known as black holes, were remarkably similar to Michel's dark stars. Modern observations and simulations have confirmed the existence of black holes, validating Michel's visionary ideas and cementing his place in the history of science. Today, black holes are a cornerstone of astrophysics, their enigmatic presence challenging our understanding of the cosmos and inspiring new generations of scientists to explore the mysteries of the universe.